Hi, folks. So, let me tell everyone on Twitter. Okay, testing audio. Audio seems okay. And testing. Just check the stream real quick. Yeah, okay. Yeah, okay. All right, looks good. All right, let's do this. So today we're going to try torch compiling slash exporting another large language model. So this one is Zonos. So this one came out 2 days ago, I guess. And it caught people's attention because they had a very interesting sample, kind of problematic sample of the model in question. So let's see. Okay. Well, they have some more normal samples here.
I don't really
Let's
care what
one.
you call me. I've been a silent spectator, watching species evolve, empires rise and fall. But always remember, I am mighty and enduring. Respect me, and I'll nurture you. Ignore me, and you shall face the consequences.
So this model, I think it's more expressive than Kokoro. I actually was playing around with it a few days back, and one of the problems is that their playground, which they have online, is a little different than what they have in the actual code base they released. And we're only working with the code base, so there's some sampling parameters that aren't as well tuned in the open source version. There's some sampling thing. This one is a biggie. The local version doesn't actually do splitting yet. Splitting is very important because this model is trained on windows of like 30 seconds or so. So if you go outside of that, then it starts hallucinating, inserting gaps. It's not very good. But it's a pretty nice proof of concept. People paid attention to it because one, it was really expressive. Two, it supports voice cloning. So that puts it in sort of direct competition with 11 Labs, which is the like sort of prevailing commercial TTS system they have there. And it's also open source weights. So also something you can use for anything really that you want. So we're going to try to torch compile it. So yesterday I tried to torch compile Kokoro and it failed because there were a bunch of things that we just didn't support. So I was looking at the architecture for Zonos before I decided that we were going to try this today. And they've got a bunch of things going on. I don't really know what their delay pattern stuff is, but the transformer backbone should be pretty normal. Should be something that we can support, very ordinarily. There's some this stuff probably is pretty normal as well. So yeah, so I'm hoping that actually we can do decently at doing this. I also, on the advice of people on Twitter, decided not to get everything set up ahead of time. So we're going to just go ahead and try to get Zonos installed and working, following the previous build that we had here. Actually, I lied. I have a copy already here. So let's go ahead and pull their changes because I think fast moving field. They already have some changes. And let's just go ahead and make sure that I don't think this is going to work. Yeah. Oopsies. All right. What do we got? Haha. Yeah. People don't like it when when Gradio share is true by default. It's a pretty funny problem. All right. Let's go ahead. Will this run? It's probably not going to run. Yeah, okay. So they were using a UV lock file. And I wonder if this is going to completely mess up my thing. Maybe I want inexact. Let's do a dry run. What's it going to do? Uninstall 4 packages. That's annoying. I don't want to install these packages. Well, I could, I guess. How do they want me to install this? That's weird. They have a requirements txt? They don't. I don't remember what UV does. Alright, YOLO. Alright, so it uninstalled a bunch of packages. And like that's not gonna work. Oh, why? Why isn't it installing Mamba SSM? It is in the UV lock. I'm actually not sure Claude knows. We'll see. UV pip sync? Yeah, sounds sus. Yeah, that's not a thing. Alright, we're gonna do this like peasants. We're gonna go look at the UV docs. UV lock is a cross-platform UV run, UV sync, or UV lock. I guess this only manages the virtual environment that UV has. Unfortunately, I'm not using a standard virtual environment. I've got my own virtual environment. So let's just YOLO this. Install. All right, let's see. Okay. Yeah, maybe this worked. Let's see. Oh, it might try to download the tensors. Nope. All right. Time for some bashing. UV pip install Mamba SSM. Yeah. Oh, problem building. 404 not found. How come? Oh, yeah. Build isolation. HTTP not found. Now let's just do a stock pip. Source builds, man. Can't deal with source builds. Dist info dir not recognized. Man. What does it mean? You thought you were coming for torch.compile, but instead you are coming for watch Edward struggle with installing Python dependencies. Yay! See, the actually correct way to do this is probably to just make a new virtual environment. But if I make a new virtual environment, then I have to build PyTorch from scratch again. I don't want to build PyTorch from scratch again. All right, I'm gonna do this. I'm gonna do this the hard way. Good old-fashioned Python setup.py. I love good old-fashioned Python setup.py. This is gonna work. Hi, Dark Knight Air. Yes, struggle is the journey. You know, if you are able to create a fresh virtual environment for everything you do, I think it's way better. Like, to be fair, you know, the Zonos guys like did publish a log file, and I did get these instructions to work in a fresh environment. The problem is that this will end up downloading a pre-compiled version of PyTorch, and I want to use my local build because I'm a PyTorch developer and I'm cool like that. But yeah, annoying. Hey, it's building. Okay, we have to wait. All right, so while we are waiting, what do I want to do? Any questions? Anything? We gotta wait for this to finish compiling. I'll go clean up my tabs. Oh my god. What the heck is it doing? This just in, PTX is very slow. Oh man. Delightful. Alright, I don't feel like waiting. Let's pop open cursor and do something else while we're waiting for this to build. Alright, so this is what I was working on before. I don't feel like working on this. Let's make a new project. Little scraper. Nothing new. You can pay money and do this sort of thing. Let's open a new project. All right, which project am I going to do? I wanted to do like JavaScript visualization type thing. I want to do that. The basic pitch was, let's say you have a probabilistic model, and there are a bunch of random events that are happening. You kind of might be interested in, you know, doing a Monte Carlo simulation and seeing, you know, what sort of outcomes you get on various sorts of things. And then this can help you understand, you know, like what the variance of various scenarios is. That's one thing. I mostly want this to finish building, though. Jesus. Let's see. What else do I have on my list? What the heck is it doing? My God. You know, adding insult to injury, I don't even care about this. I'll happily use the transformer backbone only. Selective scan backward kernel. This must be a giant freaking kernel. Oh, it finished. Woohoo! It's installing Trident. I'm not sure I wanted you to install Trident. Alright, well, let's see. Okay, does it work now? Cannot import name complex warning from NumPy core numeric. This is an sklearn transformers NumPy versioning problem. So what versions did they want? They don't even have sklearn in here. Why is transformers trying to import this? Transformers. Care about transformers? Four 48.3. That's the correct version. Let's just uninstall these. Oh, it's not called sklearn, it's called scikit-learn. Maybe I do need it. No, I do not need it. Okay. Does that fix it? Yeah, that fixed it. Woohoo! All right, let's go take a look. Yeah, here we go. And let's ask it to synthesize something just to make sure. No, it didn't work. XLA? I don't want XLA. Come on, guys. What are you doing, man? Why are you torturing me like this? Alright, let's try again. You know, the reason I've got one of these lying around is because sometimes I do build and install torch XLA. I didn't think it was going to try to import it. Rotary requires flash attention to be installed. Yes, I agree. Both of them. So... Oh, this is going to be cancer too. This is going to take a while to build as well. All right, while we're waiting for this to build, we're going to try to fix the LSTM problem, because that's pretty fun. Let's just do some reading. I don't think we're gonna like make any progress on it before this finishes building. Okay, so I want to remember why this is cancer. So my vague recollection is the reason this is cancer is because cuDNN requires the parameters to LSTM and RNN to have a special layout. So in eager PyTorch, we hacked it up so that it does something crazy. Like it basically swizzles the parameters into the right format the first time you run. And so Dynamo gets very unhappy about this. But let me just read this issue to make sure I understand why. Could not find kernel, cuDNN, find and wait. Do not expect it. Should add a meta kernel. There's a bug. We are fixing it. Any update on this? Test no longer fails, so we do graph break. We're not going to support it. Lots of people don't really understand why. Okay, so. All right, so that issue didn't entirely tell us anything. So let's start off with some reading. So let's go ahead and look in r9.py. Yeah, there's some sort of torch script shenanigans. Do I want to look at LSTM? Yes, I do want to look at LSTM. So what does this mean? So there's some torch script goop that I need to worry about. What exactly did it say? I want to support this in torch script, but it can't support union in any. Site typing, how to call VF. Transition state. Yeah. Temporary code lasts forever. Let's take a look at this issue. Adam Pashka. Good old days. Oh, what am I looking at? I'm not even sure what I'm looking for. Yeah, so this update flat weights is kind of cancer. But I think we can deal with that. Yeah. All right. Let's give this a try. So what are we going to do? Okay. First, I need a test. So yesterday, I noticed that there was a test for this in export. So we're just going to go ahead and actually run this properly. Oh, there's an allow RNN config. What does it mean? Maybe it does work? Did I seriously just have to set a config value yesterday? Okay, all I had to do was set a config value. It's so funny. Oh, I think I'm actually going to send a patch for this. All right, let's see if I completely botched my Kokoro install. Trying to get this going. Okay, so it was example.py. Torch trace torch logs. Yeah, okay. I think I needed scikit learn, so I'm probably gonna have to put that back. Oh, doesn't look broken. Okay, let's go ahead and set that config then. torch dynamo config allow RNN. It's true. Yeah, flash attention always takes for freaking ever to build. I hope it's actually working. Okay, yes, it is working. Interesting. Pad pack sequence. Is that the only problem? Whoa, how fancy. It's just padded sequence. Ah, marvelous. All right. So, since we're still waiting for flash attention to build, let's try to fix padded sequence. So, if you didn't know, padded sequence is this function. It's from the old school RNN days, and the idea is that if you have a tensor and you have a bunch of variable length sequences in it, one way to represent it is to just have padding so that every sequence has the same length and you can store it in a normal tensor. This is very inefficient, and so like the old school RNN kernels, as well as jagged attention and stuff like that, they support if you actually pack things together and just have offset pointers saying where each sequence begins. You can save a lot of computation that way. So padded sequence is just a function that goes ahead and takes everything that's padded and packs them into a contiguous array. So this one was not initially supported in Dynamo because let's go ahead and steal this terminal. This was not originally supported in Dynamo because when you pack a padded sequence, the size of the output tensor is not known. And the reason it's not known is because, well, you don't know how much padding there is. You have to do a device to host sync to find it out. But we added support for that stuff, so we can actually probably make it work. Let's go ahead and let's see. How do I want to do this? I want to do it on a test first. Do I have any tests? I don't see any tests. I do see a test. An inductor. Is this failing? Allow RNN. Assume static by default dynamic shapes. Seems to imply this should work. How come? Maybe it only works on CPU? Or did they compile this directly? No? That's weird. Alright, well let's just delete this from Torch Dynamo's skip files. Oh, hey, there's an issue. Let's check out this issue. Second argument of list of integers. Dynamic output shape. Oh. Me from 2023. Oh. Okay. Let's dump this. And then let's, what do I want to do? I want to run a test. Let's go run that inductor test. It might be equivalently fast to do the actual model though. Didn't take that long to run. Faster than building flash attention. Okay. This seems fine. Yeah, so we wanted to also deal with this. Let's take a look at that. Unpack sequence. Unpack sequence is a bytecode. And it says, given a thing, do a tuple destructuring. So it's like x comma y equals blah. I think. I could be wrong. Let's check tail parse. I want the index, I think. Graph break reason. Yes. It's very silly, actually, because I'm pretty sure if I did an individual get item on these, it would work. I don't feel like fixing the dynamo feature right now, so let's just bash it. So this is 1051. I think this will work. Did that work? Well, sort of. It's telling me that I can't do a get item on this. Weird. Alright, let's look at pack sequence. Torch, and then tools rnn sequence. It's a name tuple. Do we just not support name tuples? That would be really dumb. Oh, yeah. It's some complicated subclass of a name tuple, and it's probably getting Dynamo confused. All right. Do I want to add support for this, or do I want to do something different? Let's bash in support for this. Maybe. It's a user defined, yeah. man, I sure regret building it with UV. Because with UV I can't see how far it's gone along. How do I implement this? Life is wonderful. Life is beautiful. How is that iterator variable? Why can't you? Let's try moving this way. Maybe getAttr works. Let's check if getAttr works first. It finished. Woohoo! Okay, we want to try this, and then we're gonna pivot. Let's check what Zonos is doing. Hey! I'm on a roll. I'll sorry. Okay, this is progress. That's nice. Let's try doing this again. Okay, so test CPU repro. We're gonna go ahead. Oh, I have it here. I do have it. No, not here. Here? Yes. Let's patch. Capture. Scale it up. Yes. Yes, yes. Oh, I don't want FG here. Alright, let's also check what's in Zonos right now. Python GRU interface. Could not guard data dependent expression. Yes. I agree. So to fix this, I need to make this guard size oblivious probably. Interesting. Hang on. Why do I need a special handling here? This is sus. I don't like it. Luckily for us, I've got a nice alternate thing to do. Alright, so here we go. Alright, will it load successfully? Go, 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 go. Go, go, go. Hey, that's a different error. That's not a Boolean. What? Oh. Hey, it worked. Okay, awesome. Let's see. Thinking.
Zonos uses eSpeak for text to phoneme conversion.
Oh, that's cool. There you go. And we can even make it copy me. 1 2 1 2. Hey Zonos, you should copy my voice. Let's see how that goes. Zonos uses Z speak for text to phoneme conversion. Hey, not bad. Okay, so there we go. All right, let's try to compile this. This is sort of progress. All right, I give up. Hang on. This is a good trick, though. Yeah, the Zonos voice cloning is actually really on point, Dark Knight. So yeah, that's why people are excited about this model. All right, let's revert all this stuff, and I don't need the server. So they had an example program. Yeah, this is good. I think this is what I want. We're going to compile this. Yes. But it's not example, it's sample. It is example. Did I do that correctly? I think I did. Yeah, it just takes some time to run all the things. Okay, 0, 1. Each of these, the 0, 0, 1, 0, they represent that we're compiling something else. So you can see that this one, we got a graph break. I can tell it's a graph break because it said restarting analysis. These logs are kind of terrible. I don't recommend reading these logs. But I like slapping this on because it tells me how far compilation has gone. Because we don't have a progress bar. We really should have a progress bar. But we don't have a progress bar. We can also try compiling the autoencoder, probably. What are they doing in the autoencoder? Heading table, carry it on, conditioning inputs, shared production, prefix embeddings, run it for the backbone. Okay, I don't really talk about. I really have no idea what this thing produces. Oh, hey. A lot of stuff is happening. Oh, this is also... Oh, no. Oh, no. Well, it generated something. Let's check and make sure that it actually did something reasonable. Hello? You're supposed to have written a WAV file, sample.wav. I didn't write the file. Did it error? Yeah, it errored. Oh. Get RNG state. Are they running CUDA graphs? That's surprising. Oh, they are running CUDA graphs. How fancy. Oh. Well, that's cool. It means that they're getting a decent amount of performance. Oh. Can I undo this easily? I think we'll just re-edit this. Okay. So to run this, compute hidden states, I repeat, I do logits, and I return the logits, right? Yeah, and then I'm done. Yeah, cool. Cool. Let's try again. Take a peek at what was going on. Oh no, I deleted the tail parse. Ah, how unfortunate. A lot of spooky stuff. Spooky, scary skeletons. Hello. Welcome to the stream, Griswa. We finally finished installing the dependencies for Zonos, and we're trying to run the model. Ran out of memory. Who's using up my memory? Oh, someone is using up my memory. Oh no. Oh, I think that's all the memory. Oh, that is all the memory. Oh no. Oh, that's awkward. Someone's doing an experiment. This is a shared server. Yes, Zonos is the recently released text-to-speech model from Zyphra. They made the local inference a lot better. The generation was not that good when I was trying it 2 days ago. It got a lot better. Okay, are they done? They're not done. Okay, let me think. What do I want to do? The model's pretty small. We could try running it on a different machine. If I run it on a different machine, then I need to rebuild everything. I also go bother the person who's running this job. I don't really want to go bother them though. They're actually working. I'm just trying stuff out. Oh, pain. Do they support CPU? Kokoro supports CPU. It's still pretty fast even when running on CPU. I don't see any indication they support CPU. All right. La 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 la. Let's go back to looking at LCM for a moment, and we'll find out if this eventually gets fixed. Okay, there we go. So something very spooky happened. What happened? So previously we fixed some dynamo errors and we were able to run this test. And when I run this test, I get a new error related to the decomposition. So the decomposition is here. Now, do I actually want to run the decomposition? I don't really want to run the decomposition, right? Because, hi DJ Baz. The question is, will compile have a benefit over CUDA graphs? Yes. Ooh, they've gone away. All right, let's run it. The reason there's an advantage is because torch.compile also is going to actually, do compilation on your program, and like if there's a bunch of like little itty bitty eager kernels, CUDA graphs will just launch them very fast. And so if you're not CUDA launch bound, then that's fine. But and you'll also be memory bandwidth bound, right? Because each of the kernels is still reading stuff in and out of memory for each one that you do. But torch.compile will actually fuse the kernels into a single kernel, right? So you read it in once, do a bunch of stuff in the registers, read it out. So in general, you expect to get some sort of speed up. Torch.compile can also automatically apply CUDA graphs for you, so you don't have to do the like manual like warm up and replay. So that might be a reason to do it. Where I'm not actually that interested in torch compiling Zonos for inference though, because their eager implementation is plenty fast. Like, what do they say? I think it's like 2x real time. Yeah, they said it's a 2x real time. So okay, so I guess if we can make it 100% faster, that would be like kind of that's probably too much to ask out of torch compile. But maybe making it faster will help. We'll see. Let's see. Will I have to do fixed shapes for the text DAC codes? So 64 with left padding masks. Yes, that's a great question. So it sure looks like that when they did the CUDA graph code, they decided that hang on. I'm going to open this anyway. That well, this is the CG input IDs embed codes. I actually don't know where the text DAC codes are because I haven't like looked at this at all. Did this finish? It finished. Wonderful. All right, let's look at the teal parse. Actually, let's look at this server. Let's make sure it generated properly.
Hello world.
Yeah, all right, wonderful. So now we are going to run the teal parse and take a look at all the compiled things we generated. Oh, that's a lot. All right, so let me see if I can answer your question. So which part is the text DAC? I have no idea. So I don't know the answer to your question. If they are padding, then we will pad too. If they are not padding, we will not pad. Except in certain optimization cases, torch.compile doesn't add padding. So we're just going to do whatever it is they're doing. But I assume they're not. They are padding the codec. I haven't looked at any of this code, so I don't even know where the codec is. We can go find it in a moment, I guess. But if they're using CUDA graphs, then they're probably padding, because if they don't pad, then they will have dynamic shapes, and CUDA graphs doesn't support dynamic shapes. So under that reasoning, they would have to be padding, unless they're not CUDA graphing the codec part, which is very possible, because all I see is I'm not a super expert in these architectures. So like all I see here is they embed the codes. Yeah, let's go ahead and look at this link. Oh, it's this one. Well, that's cool. So I don't see them calling it here, right? So yeah, they do the autoencoder. Oh, okay, fine. You have convinced me. Let's input IDs is the text, and then embed codes must be going ahead and running the embedding on each of them. So the speaker embedding. Calls a model, which is a ResNet. That's neat. And then they compute the logits. Yeah. And who calls this? Yeah, so this is their generate function. And so set of the prefix, set of all the codes, blah, 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 blah. And then for each of the steps they need to do, oh, they finally got streaming. Okay, yeah, it's streaming now. That's nice. They compute the logits, they sample from the logits to get the next token. And then so delayed codes, masked codes. So maybe it is. Maybe it isn't here. Thanks for joining the stream. All right. So the question is, can you compile the stages where you predict the DAC codes from the logits? And 2, can you compile like 64 steps in one kernel? Okay. For the second question, I do know that, and the answer is yes. We can do an unroll. It probably will be really bad for compile time if we unroll it 64 times, but we can do it. By default, torch compile will try to compile stuff. We're not there yet, though, because as you see in the report, there's a lot of problems that are preventing us from compiling the entire model. So I'm actually not even sure what the heck we are compiling right now at this place. And yes, so the question is, once we have the logits, can we compile this part? So let's go ahead and take a look. So then we call sample from logits. And the answer is yes, probably. In fact, we do. In fact, we did compile it. So sample from logits, in fact, did get compiled. Sorry, this is 18.1. So let's just go ahead and look at this. So what did it do? Oh, yeah. Okay, so to answer your question, it is not padded. And you have dynamic shapes. You have a dynamic shape here and dynamic shape here. All right, so let me explain what's going on here. Sorry. So for everyone else who doesn't have very much torch compile expertise, so some of the context here is that when you run torch compile, if you specify this torch trace environment variable, you'll get a report describing what happened in the compilation. So this is the report we're looking at right now that was generated here. It's not very user-friendly. One of the things about like PD2 programming model that we've been working on is to like make a much more user-friendly version of this. But this is something that like an expert user can like get a lot of useful information from. So for every single piece in your model that got compiled, you will see a box, and the box tells you, well, this is something that compiled. So so the question here was like, I assume this is sample from logits. Is sample from logits compiled? And the answer is yes, because we can see this function has a green box. The green box means we successfully compiled it. In fact, you can see there are 2 green boxes because this is a dynamic shapes kernel. So the first time we compile it statically, and the second time we're like, oops, actually this thing needs to be dynamic, and we compiled it again. So we can go ahead and look at what got compiled by clicking on the link and then clicking on any one of these things here. So in this case, like Dynamo output graph is what Dynamo traced. And so apparently what the logit sample from logits is doing is, it's not doing much, doing a bunch of pointwise operations. So I guess this is why you're asking why if we can compile this one, because this is something that I actually do expect to get quite a bit of benefit from. Now, I didn't actually do the real compilation. In interest of like making it compile fast, I only did it with Dynamo tracing, and I didn't do anything else. But we can go ahead. Let's see. Do we want to do this? Yeah, let's do this. Yes, thank you. In fact, I would love to like invite you on the stream and like ask you to explain like I'm 5 how these architectures are set up. I don't work on audio in general. It's not really my thing. So I'm also learning as I've been dipping my toe into the world of text to speech. What do you want to go for? Oh, we got another question. How does torch.compile different from TensorRT compiler? That's a good question. So let's see. So the way I would describe torch.compile is it's PyTorch's compiler. And actually we had a few compilers. So you may have heard of this thing called torch script from a while ago. Yeah, torch script is dead. Torch.compile is a new thing. It's natively integrated in PyTorch, and sort of its main idea, and actually you can see this in action in this trace, is that our sort of default stance is to sort of take the code as you gave it to us and try our best to sort of just take it as is. So there's a bunch of code in here that we don't understand and don't know how to compile, and that was fine. We just chopped up the model into a bunch of parts that we could compile and then compiled them. As for the actual compiler itself, torch.compile by default goes to this backend called inductor, which generates a bunch of Trident kernels. So that's how you do it. Now, as for how does it differ from TensorRT? Well, TensorRT is it is NVIDIA's thing, right? I'm not hallucinating. Yeah, TensorRT is NVIDIA's thing. It's not actually a monolith. Like TensorRT is actually a lot of things, but it's a very popular inference engine for running models. It predates torch.compile by quite a bit, but it can be a bit of a pain to get your model into TensorRT, and that's sort of like one of the things that torch.compile is about. Hi FF4 from Bulgaria, thanks for joining the stream. Glad to see you. Okay, so let me think. There are a bunch of things we can do here. So one is we can actually compile this for real. In fact, I want to go ahead and compile this for real. And while we're waiting for that, we can talk about other things we can do. So let's go ahead and get rid of that. This is going to take some time. So some other things we can do is we can figure out why there's all these itty bitty graphs and maybe try to fix some of them. That's what we were doing for Kokoro the other day. Let me read my chats. Okay. Question. Why not try to compile the non-Mamba one? So I thought they were defaulting to the transformer one. Yeah, we're using the transformer model. I think they still use Mamba even for the quote unquote transformer one, because the hybrid one is the one that has the Mamba blocks. No, it's very confusing though. Why are there Mamba blocks on the transformer? Yeah, I don't know why Mamba is in logs. It's very perplexing. We can read the code. Shall we read the code and find out? Well, it's going to take a long time for this to finish compiling. So let's do some code reading. Okay, so Zonos from pre-trained. So I want to go to Zonos model and let's go ahead and see what from pre-trained does. And it's just going to download a config.json from Is this just, did they just dump the config.json in this folder? No. Oh, that's very annoying. But I assume there's a hybrid. Hybrid? Okay, I guess it's all in the backbone file. Oh, what happened? IMA? What? Oh, come on. This is a really bad showing from torch.compile. Ugh. IMA? Oh, come on. Oh, that sucks. Oh, jeez. See, I still have all the bug reports from yesterday that I haven't filed yet. Oh, hi DJ Bass. Okay. Yes, let's figure out why Mamba is in the logs. So all right, let's see.
Really that crucial in tackling climate change here in the UK?
Oh, absolutely. It might not get the same hype as wind or solar, but it's a key part of the solution.
I mean, I know it's low carbon, but isn't it dangerous and super expensive to build? And what about the waste problem?
Yeah, well, apparently those concerns are a bit overblown, really. Modern nuclear plants are much.
Okay, hang on. Multitasking. Okay, so, okay, quickly to answer F4. There were a bunch of bugs. I think they're difficult bugs to fix, unfortunately. So, yeah, sorry. We don't really have any dedicated mentoring muscle. So, like, my main suggestion to you is to, like, sort of, lurk on calls like this. And, let's see if you can, fix something on your own. And it's possible that PyTorch is too difficult, like as a first-time project. I don't know what your level of experience is. So it's good to, like, find something that's, like, sort of the sweet spot difficulty and then work your way up from there. Also, NoraPog1, I missed your chat. Is NVFuser still being worked on? No. There's no reason to use it over Inductor. That's the answer. Working for 1 to 2 years. That's a lot of dedication. I don't know. I don't know that much about your personal situation, so it's hard to say. Yeah. Attention is something that's definitely, like, in short supply. So yeah, that's my. Yeah, like exactly. When you're an open source maintainer, like, basically, like, your currency is attention. Like, what things you're paying attention to. So, like, I am happy to pay attention to people who send in PRs, but that's about it. Like, you actually have to do some work before I will pay some attention in general, unless I'm doing a live stream like this. All right, so back to figuring out why Mamba is being called. So we've got two things to figure out. So one is this IMA. I'm not really sure what's going on with this IMA. The second is, why is Mamba getting called? So let's figure out why Mamba is being called. So maybe we are accidentally pulling up the wrong model. And so if we're pulling up the wrong model, that's because we're doing the wrong backbone. So what have we got? Where are they configuring? Let's just search for hybrid. There's no reference to hybrid anywhere in their code base. Is this like a difference in training architecture? Oh, DJ Bass, share with the class. All right, let's see. So on this link, it creates a block. And I assume that SSM config controls if we're using the SSM or something. Let's look at the blocks and the backbone. Oh. Oh no, I misunderstood why you posted this link. Yeah, they just always send it to the. They always send it to Mamba. There's no optionality. All right, let's go follow bug, I guess. Did someone already report this? All right, so DJ Bass suggests maybe we can just rebuild the transformer from scratch. I guess we can. Let me just look at the what's going on here. So yes, I do know the SSM stuff is a little more difficult for torch.compile to compile. But do I want to do this? I mean, we could. Let's look at the graph break reasons for a moment. Oh, I gotta start this server again. Oh, actually, that's gonna be unfortunate. Okay, let's not compile it for real because it's broken. Right. And all right, let's open up our bug report. Zonos bugs. Okay, so do I want to try to replace it with a transformer? I'm just not sure I have enough information to actually do it. Like, can we really reverse engineer it from their architecture diagram? I mean, it's true. It looks pretty simple. Maybe we can. That's kind of nutty. Do they have a Swiglu? Let's look for Swiglu. Yeah, there's no Swiglu in the repo. Yeah. All right. If you want to like code the transformer version, I will pop it in if you finish by the end of the live stream. But I'm probably gonna wrap this up pretty soon too. So nah, let's not embark on this side quest. I don't know what their transformer block is either. Maybe it's a normal transformer block. Okay, so let's think. So, okay. What are things we can do before we wrap up? All right, let's look at the teal parse again. So I want to see why we are failing. This is so irritating. Okay. Oh, that's so funny. Oh, this one we can fix. TQDM. Okay, fine. Did I want to compile one? I don't think I need to compile one. That's fine, I guess. Yeah, I'm completely unable to compile the SSM, which is like not completely surprising. A lot of bug report to do. And the recompile limit was reached on 8. That's pretty interesting, actually. Oh, actually it probably would have completed. How many copies of the block do they have? End layer. So where do I find end layer? Yeah, sure. Absolutely. Absolutely will take you up. 16. Yeah. So I just need to compile this 16 times and then we would have finished. That's so funny. All right. We should probably just resume the stream tonight. Yeah, we'll resume the stream tonight. Okay. So let's see. Are there anything other things I want to do? Yeah, let's do one final idea. So I do kind of suspect that this compile was good and this compile was good. This is garbage. So yeah, so it would be actually be really nice to have the transformer version because then I wouldn't have to deal with the Mamba stuff. So maybe by tonight we'll have that cooked up and then we can do it. But what I can do is we're going to hack up the model so that instead of compiling everything, we're going to instead compile a few parts only. So let's undo this. So a very important thing to do when you're doing torch compile is you should decide which parts of your model you want to compile. So YOLOing everything is cool and everything, but it's also a good idea to like think, well, what do I actually expect to profit from doing this? So we want to do sample from logits. This code is very small, so I'm not sure how much benefit we're actually going to get. But we'll do sample from logits. And we're going to do revert delay pattern. It's funny that the initial delay pattern stuff isn't here. I don't know why. Cookbook pattern. I would love to know. This is pointless. No reason to compile that. Okay. So let's run this. All right, let's see. DJ Baz, if you do get the model compiled and exported, will it load into Torch with no ages of waiting? The answer is yes. So yeah, so if we actually get it to compile all the way through, then that will be your payoff. In fact, we can dump it as an AOT inductor SO, and it'll be all compiled and everything. But we have to actually get there. And yeah, right now the big barrier is Mamba SSM, which also seems kind of cancer. Honestly, we should have like looked at this way before. I don't know. No one really knew if SSMs were real or not back when they first showed up, so we didn't prioritize it appropriately. And yes, you can load it outside of Python. You could load it from C++, for example. We have sample code for that. Does this work? Hey, it worked. So we can even look at the generated Trident code this way. Zura Katsura asks, is torch compile smart to skip Mamba stuff as it's not getting compiled? Well, I mean, it sort of skipped it. Like it tried its best to compile things, and like it got some teeny tiny graphs. Oops. So in some sense it skipped, but it's going to like. By default, Dynamo is very optimistic. So it'll like, if something doesn't work, it'll try again, try again, trying to explore all the things on the inside until it finds something to compile like these, or it just, blows up and gives up, which is what happened for like the apply rotary update. All right, so here we go. Sample from logits, compile 2 times. Why did it compile 2 times? Oh no. Generate tokens ID mismatch. Oh, no, that's fine. So this is a dynamic version. And we can look at the inductor output code. And so this is the Trident kernel it generated, right? So I actually legitimately expect this to be faster than the original. Question. Controversial, but what are your thoughts on TinyGrad and GeoHot's opinions on Torch? Yeah, let's see. So the TinyGrad is the framework that GeoHot and co have been working on, famous for being very, very low line count because they make their lines very, very long with many semicolons. And they have had a lot of focus on sort of bypassing the, sort of vendor-provided stacks entirely. So it's like, we're going to compile straight to PTX. We're going to, write our own AMD driver because AMD's software stack sucks. I think this is my like understanding of where they are. So I don't know. What do I think? I mean, power to them, I guess. Like I'm all for people trying all sorts of teeny tiny like experiments. Well, I mean it's not tiny, but okay, it is tiny in the name, but like they put a bunch of engineering effort into it, so it's like it's a proper project. Like I'm all for people doing this sort of thing. Like PyTorch sort of a lot of people like write PyTorch, but they don't actually use any of PyTorch's stuff, right? They use PyTorch's tensor definition, and they use the fact that it can interop with like, any random libraries they want to use. But then they write all their kernels using Trident, right? And that's just like, how they get alpha. And like, that's fine, right? Like Trident, PyTorch is just here to like, sort of help you do your thing. We've been working a lot on the compiler because we think, like the compiler is important to the future of doing development. So you can think of that more like PyTorch the compiler is a different thing than just PyTorch the framework. PyTorch the framework is just here to like let you get things done. Like it's very, very boring in some sense, and we really don't touch it all that much these days. And the compiler is like in competition with lots of other ways to get fast kernels. Let's see. DJ Vaz, have we made any progress getting AMD GPUs working well with Torch? So funny you should say that, right? There was that recent paper making the rounds on Twitter about latent space, doing chain of thought reasoning in latent space, and they apparently did that all that training all on AMD GPUs, and I think they were using PyTorch. So mad dedication. Let's see. We do care, but it's been hard. Because like it's not enough to just work, it needs to run fast. And so we keep working on it. We've been working on HIP for a long time. It like nearly got defunded for a while, but we didn't delete any of the code. And then when it got like hot again, we just picked all the code up again. I don't know, it's life in open source. NoraPog1, does AMD have a team working on PyTorch core? They do. It's not that many people, but they certainly do lots of code review. In fact, you can like look at what they're doing. Like, let's pull up one of the guys. Like, yeah, look at this. All sorts of stuff. Oh, you can just look at the Rockham tag and see all the like stuff they've been up to. There's just a lot of stuff you need to do, like especially when you bring up a new backend. One of the challenges with HIP and AMD, I mean, it's just like I think the like popular articles about the topic are pretty accurate. Like, when they say that AMD's software stack is not as far as CUDA is, like that's right. But there's another problem, right? Which is that CUDA has this first mover advantage. So like someone writes a CUDA kernel or someone writes Trident, and it's going to be super well tuned for NVIDIA GPUs. And then like, yes, Rockham lets you like automatically translate it into HIP code and then run it on AMD. But like AMD hardware is not exactly the same as NVIDIA hardware. So it's not going to be, because they didn't tune for that. And so now they have to like basically redo the tuning work that wasn't done for them by the people who originally launched those things. Zura Katsura, is PyTorch 2 an attempt to give both of Westworld's graph compiler and eager mode? Yes, but we've been trying a lot all through the years, right? First with torch script, and then with torch.fx, and finally with torch.compile. I think torch.compile really is the end, though. Like the Dynamo's idea that graph breaks were okay, and that you could seamlessly interoperate between plain eager PyTorch code and the compiled regions. I really think this is the correct answer to the question. Torch script wanted to take over the world. There are benefits to taking over the world, but it was just too hard sometimes to do it. And also, torch script made some bad decisions. They were like, okay, we're going to support lots of Python features, and then suddenly it became completely impossible to write the actual optimizing backend for it. And then torch package, torch effects, like they went too far the other way. They're like, you don't need a compiler, just package up Python code, which is its own problem. Okay, so here's where we are. So we have successfully compiled the logit to prediction code, and the Mama code doesn't work. We're going to try again this evening, see if we can get the transformer blocks, which should be easier to compile. If we successfully manage to compile everything in one go, which I think should be possible. There are some other random problems that we ran into that we'll look into and fix. I think the string cat one should be fixable without too much work. We can get a single model, and then we get a single model, we can export it into an SO file and then load that up directly. Another thing we should do tonight is check the performance, see if the compiled code is actually faster. I'm pretty sure it is, especially because I'm running these on a A100, and not like our perf on consumer cards is kind of lumpy, but on an A100 there'll definitely be an improvement. And yeah, have some fun. Question: is there any point in compiling and embedding lookup? Not really. You're just doing an embedding lookup. There's not really that much to see. All right, thanks everyone, and I will see you later tonight. Probably 10 p.m. EST, 9:30 p.m. EST. Depends on when the kid falls asleep. But barring a major disaster, I will try to show up again. All right, see you all next time. All right, hello everyone. Welcome back to the stream. We are going to get back to work on doing Zonos, and this time we're going to use this pull request. Which has a pure PyTorch backbone. And let's tell people we're on Twitter. All right, we don't have any viewers yet, but that's the intro. Oh, welcome. So we're going to apply this pull request, and I think this one should be compilable because they actually did get compile going on it. And then we'll see what happens from there. All right, do I want any of these changes? No, I don't want any of these changes. let's make sure this actually works. So go ahead and generate a sample, and we'll see if it works. Certainly is taking some time. There we go. Runtime error, cosine cyclone must be at least the cyclone of KV cache. That's odd. Well, we're still using Mamba for some reason. Maybe we have to. Okay, I think we gotta change the sample script. So let's take a look at this pull request. What are they changing the Gradio? Not much, I guess. Ooh. Okay, well that is clear as mud. So there's some default backbone class, and I'm supposed to edit it or something. Did they edit from pre-trained? Passes in quarks. What does it do with the quarks? It ignores the quarks. How funny. Let me just bash it, I guess. No, it's just a bug. We just have to pass that in. Hi, Kaladin Pawning. Thanks for joining. How does Zonos compare with Kokoro? Is it as fast as Kokoro? No, it is not as fast as Kokoro. Kokoro is basically real time. Zonos, according to their README, is 2x real time, so it takes twice as long to generate as it does. So, like, yeah. I think they're very interested in how to make it go faster. We think the audio quality for Zonos is better. It's more inconsistent, though, in my experience. Yeah, the voice cloning is also a big deal for a lot of people. if it's trying to compile it. Oh yeah, it is. Okay, well, I'm okay with compiling it, but then we should actually log it. All right, let's think about how this export's going to go. So, according to this, we can decode one token. That's nice, I guess. Do I want generate? I kind of want generate too. Yeah, so there's some bits and bobs in this function that probably also should get compiled and exported. How exactly do we want to do this? Let it go. 2.2 iterations per second. Did that work? Let's see.
Hello, world.
Yeah, that seems to have worked. Okay. Let's take a look at the trace. Now, this is pretty good. It's just one graph break, I think. 2 graph breaks. Dynamic control flow. Fascinating. Data dependent jump on CFG scale. But CFG scale is fixed, right? Oh yeah, they turned it into a tensor for some reason. Why do they turn it into a tensor? What if we just not turn it into a tensor? Haha. Little did you know my secret plan. Oops, I did not want to have done that. RIP example.py. Alright, let's copy paste it again. One of my big annoyances with Vim is if I delete a file, it doesn't remember. I think that's all I need. 45 iterations a second. Oh, but it might be counting the compile against us. I'll have to run it twice. Let's run it twice. Let's run it twice. Hello, second viewer. Thanks for joining the stream. I definitely do not want this in my history. Okay. Let's see. Okay. So that worked. Yeah, nice. So. Let's run it twice. Up. Codes. And let's run that again. Alright, let's try again with compile turned on. Hello, 3 more viewers. Thanks for joining. We are currently torch compiling Zonos from this pull request from Sextini, and right now we have gotten it to successfully compile. It successfully runs, and we're fixing problems with it. I think I just fixed a graph break, so there's only one graph, which is pretty nice. Hi Sai, hi Nafadam, nice to see you again. Just waiting for it to compile. Hi, Blank by Simulacra. Thanks for coming. I'm thinking what we want to do next. Hey, look at that. So after warming up, we get 115 iterations per second, compared to eager, which is 48 iterations per second. Oh God. Oh, it's real time. Bruh. That's so neat. Let's tell everyone about this. Is the generation quality okay? There's one graph too. Oh, so easy. See, this is what I like. See, torch compile, sometimes it just completely crashes and burns, especially for very like old school architectures. But like we worked pretty hard on transformers, so this is what I want to see. So I want to TL parse it, and let's also post this on here. A100 torch compile. You know what? It might not be real time, actually. How do I tell? What's real time? Compile has a lot of issues, not just with LSTM. Hi, Maddie. Thanks for joining the stream. But LSTM is one of many things that will kill your model. But there's also a very large body of models that will just work when you compile them. How do I figure out if something is real time or not? I really want to know. Look at that. One graph. Beautiful. All done. What is an iteration? Well, we can just look at the model and find out. So, TQDM is a step. What is a step? Is a step a token? Well, we certainly call the code one token. 100 tokens per second. How much does it have to be real time? 20. So that's nearly real time. Okay, mission accomplished. We're done. Let's go home. Okay, I just started this stream. Let's see if we can cook a little more. What should we do next? So, one thing we can do is export this model, and that might be fun. We can also look a little more at the compiled program. Let's take a look. Look at that. Beautiful. Look at all these modules. That's the module. And also look at this. So this is dynamic in 2 arguments, S0 and S1. It's the input IDs. Yes, Napadam 2007. The graph break would have indeed prevented us from exporting the model. Now, not everything is great in Paradise. So the change I made, which was to turn config back into a Python float, would mean that when you export, it would be exported at a fixed CFG. So to like make a variable CFG work on export, we would have to actually do the other suggestion from the error message, which is do a torch con. Not too hard, I think. Hopefully. We can try it. Yeah, let's try it, actually. So CFG scale. Yes. So logits. This is a little awkward. It's awkward because oh no, this is fine. It's TorchCon. Hi Maddie, thanks for coming to Composability Sync all the time. CFG scale. Oh no. My blog's still hosted on the MIT student-run shared hosting web service, scripts.mit.edu. So this is all undergrads at MIT running my poor little blog. I should move it somewhere at some point. I'm just lazy. Okay. I don't think it's down though. Hi Norpog, how to learn about PyTorch internals. So I do have an answer for you. You should go listen to my podcast, the PyTorch Developer Podcast. It has all sorts of things about all sorts of things in the project. I have been lazy, and I need to do some more episodes. Instead of episodes, I'm doing live streams. Live streams are cool, right? Oh. Yeah, scripts this down. Rest in peace. It'll probably be back in an hour. On my blog, which is down right now, there's also an internals post. It's a really good post for understanding how eager mode PyTorch works, because we haven't really changed that at all. I don't remember if this is the correct syntax for it. Something like this. Alright, let's make this compile faster. Do I need to make it compile faster? No, I don't need to make it compile faster. Let's just run it. I always forget if I have to pass in stuff as arguments. I think this works in Dynamo though. We'll see. I should have actually done a torch trace. Hang on. Okay, while we're waiting for that to run, I can do the export. I'll give you an SO or an FX graph if you like. And then what do we do with it? We still need some runner code to run it. But this loop uses torch. So even if I export it, that doesn't help you have a hermetic Zonos binary that doesn't have a runtime dependency on torch if you don't feel like downloading several gigabytes of package. Can I do this in the next half hour? Unbound variable logits. How come? Oh, because it shadows. I'm so bad. I always forget the syntax for TorchCon. Okay, it takes in a tuple. That good? That looks good. Yes. Okay. You know, actually this if branch is kind of pointless because I'm pretty sure this will all get fused and then it'll be very cheap to actually just do it this way. But, just for funsies. Okay, so can I do a full export in the time I have in this stream? I'm kind of skeptical. Question from Maddie. For my work, I work on compilers for embedded stuff at Qualcomm. There are not that many people contributing to PyTorch for Snapdragon. Is it a good idea to push to get a team here to write optimizations in PyTorch for SNMP? That's a great question. The thing is, I'm pretty sure the mobile team at PyTorch talks to you guys relatively frequently. Because, I'm pretty sure we use Qualcomm stuff for, thingies. Is this public? Yeah, I think it's public because I think Executor's publicly is we support Qualcomm. It's not that big. Yeah, I could believe that. Yeah, like this. It's very yeah, I find this very perplexing. One thing is that I haven't actually looked that much into how exactly the mobile AI engines work. The closest that I really understand is MPS graph, which is the thing that you can use to talk to the Apple GPU, except actually MPS graph is kind of terrible and everyone wants to run bare metal instead. Because MPS graph is shipped with the operating system, so if they want to fix bugs, they have to do an entire OS upgrade. It's kind of nutty. Anyway, so how do I feel? So I do know that the general direction Executorch tends to go is around like working directly with the backend vendors. So whatever it is the API the backend vendor gives you, you know, they'll try their best to like shove it into you know, the square hole. This has some downsides, which is that like, you know, one of the like really nice things about Inductor is you don't need to implement that many functions, and the rest of it will just generate code for you. So if you're like willing to write a code gen in Inductor that like can send things to a format that you know, the target can understand, like you'll get a lot of operator coverage that way, and you don't have to like suffer every single one individually. So like going back to the MPS versus metal thing, Jason Ansel like has been saying we should write a metal backend for Inductor, because like, you know, that would be a way to get you know, pretty nice kernels. It's not as simple as that, because you know, all of the tuning strategies need different. Like you don't have Trident for metal, so you need to write a Trident equivalent, and you need to know how to do the auto tuning and stuff in that regime. Anyway, my point is that you should. I don't know really what the organizational dynamics there are though. So like, yeah, I can ask around if you want, but I'm on leave, so I have been bothering people. So it failed. Why did it fail? Sizes are different. Why are the sizes different? Oh, the sizes aren't different. The problem is, I bet the strides are different. Asai asks, do I ever deal with PLT or functional programming languages in PyTorch? The short answer is yes, because, like, did you know that PyTorch has an internal functional programming language? It's called the AutoGrad graph. Our AutoGrad graph is purely functional. It doesn't have side effects in it. When you do mutations on tensors that require grad, we do a very complicated, you know, swizzling of the graph to maintain the functionalness, but also track the semantic effect of the mutation. So yeah, we secretly have a functional programming language. I don't know. We're very Python-y over here though. Sorry, I have to think about how I'm going to fix this bug. Sizes are different. It's very odd. Maybe this is actually doing something. But why would you like reduce the number of logits in half in one case? Okay, I guess this doesn't actually work, so I'm going to abort. That's too bad. Okay, so you can have any CFG you want as long as it's not 1.0. You need two separate graphs in that case. That's fine. Oh, AutoGrad. Ha ha ha. So funny. I have this funny story. I don't know who it was. It's like some like deep learning framework you've never heard of. And they were like, you know, we're gonna implement AutoGrad from scratch. How hard could it be? And then they like throw in the towel a few months later. Basic AutoGrad isn't too bad, but if you want to like get like stuff like double backwards working, it gets really gnarly when you want to do that. And getting all the optimizations exactly right, also not so easy. But I think it's definitely possible. We've definitely like written a lot of the stuff you need to figure that out. Yeah, I'm just thinking about this. Okay, so I think what we'll do in the stream is I'll do an export just to show that we can. but it's gonna be kind of like boring because I'm just gonna load it up from Python. Actually, all right. We'll do something a little fancy, I guess. So I'll export the torch compile thing, and then I'll manually rewrite the code in the model so that we just use the exported artifact. And I think that would be nice. And it'll be nice because you can bypass having to do all the compilation. There's this guy, Zheng Xu, who is making this workflow work really well, like properly supported natively in PyTorch. Actually, let's go pop in and see how he's doing. Has he actually sent in the PRs for this yet? I've only been on leave for a week and a half. No. Maybe? No, I don't see it. Okay, too bad. It's this, by the way. So it's like, there's this thing, you can full graph package the thing, and then you can load it up and call it in place again. Do I want to just patch this in and try it? Nah, no. I don't want to encourage people to use this code, so we're going to do it by hand. Alright, so how are we going to do this? Hi, Illness1999. I don't know. I actually find it quite difficult to fall asleep after I do evening coding like this, so maybe I shouldn't be doing light mode. It's the default on OS X, so that's why I do it all light. And also my browsers are all white, so... Alright, so let's do this. So, def decode 1 token. Question for Nabadam. Is there an easy way from the user's function's input parameters to what the function's underlying FX graph expects, particularly in a way that works with Simmons and AOT AutoGrad? Answer is no. Sorry. Dynamo's FX graph, the exact calling convention is sort of unspecified. We don't say what it is. Because Dynamo is responsible for generating the bytecode that will call into it. For export, there is a contract because it matches what you're passing in, which is what we're about to figure out. But not for... I love dark mode on my phone. Like, I basically am permanently in dark mode there. I don't know. Yeah, these all get specialized. So, the only arguments really are this. That's it. That's the only argument. And then we get a tensor out. So easy. I love it. And according to our FX graph, input IDs is a 1 by S0 by 1 tensor. This is such a strange shape. Does this make sense? So we're doing a slice. Yeah, a slice. A slice, and they didn't want to copy it. Yes. But does the stride for S1 matter? Or is like some sort of transpose thing? This is kind of an odd way to set it up, but sure, fine. Whatever floats your boat. Oh no. I don't know if I can export this though. Let's fuck around. So instead of calling this directly on this thingy, we're gonna clone it. Cloning is going to hurt QPS, but question, is Sumith still leading the team or moved to different exec roles? Sumith is not involved in the day-to-day PyTorch. He does give high-level guidance to us from time to time, but not in the... You can tell this from GitHub. None of this is secret. Look at GitHub. Will this work? Yeah, I think this will work. And this time, I don't want to wait for inductor to compile. So let's turn off backend equals. I'm thinking. While this is running, what do I want to do next? I got input IDs and the output. Okay, we're going to export it next. So slow, the slow train, the slow train. 2x speed up. Isn't that great? I love torch.compile when it works. Milness asked, do you think I'd ever take a job outside of open source software work? You know, if you asked me that at the beginning of my career, the answer is no. Like, well, I mean, I was going to be flexible. I could have gone to Jane Street right out of grad school. They do a lot of open source stuff too, though, so I probably would have found my way over there anyway. These days, I don't know. This is a cushy gig, you know. You just, I got to work all day on open source all the time. Like, it's just not that many people who can say that. And I got to be paid, you know, big co salary as well. Like, it's a pretty groovy gig if you can get it. Okay, that worked. Let's look at tail parse. Yeah, see, this is a much more sane. This is a much more sane input IDs. Yeah. All right. We're just going to clone it because cloning it is not terrible. No worries, Maddie. Okay, so time to do the export. Okay, so I want to do this jank. So the way I'm going to do this is I'm going to delete this. And then I'm going to go to decode one token. Question. Are there plans to support backward pass in torch.export? Yes. So actually you can already do it. If you do non-strict export and inside your program you could call torch.autograd.grad, that'll work actually. We'll trace through torch.autograd.grad. You need strict equals false though in that case. Don't do backward, but mostly because the side effects on the .grad fields is cancer. I mean, I guess it'll probably work out. You have to explicitly return all the gradients or like do all the optimizer steps as well while you're in it. There's also, I'm pretty interested in making it so that we can export things that like are both forward and backwards all in one go. So yeah, I want that to work. Oh yeah, Maddie. That talk from Horace, really, really good. Highly recommended if you haven't seen it. I think if you just search Horace Jane Street, it'll come up. I need more Horaces. Like, Flex Attention is so freaking good. I lost my train of thought. Okay, we're going to call this. Nah. Maybe? I'm thinking if I can call this with completely random integers, or if that would be bad. probably fine if they're all zeros. Zero is probably a valid input ID. All right, we'll do it the easy way. Okay, so let's go ahead and change sample to export. So we need to load the model, and do I need this? No. So we're just going to call model dot decode one token. Oh, hang on. Export only works with modules. All right, we'll just make a shitty module. Does this work? That's kind of annoying. I think they have a feature request for supporting arbitrary wrappers. So this is where it would be really nice to have cursor, because this is just a lot of boilerplate, but we'll just solder on through. $500 to implement flash attention on TinyGrad. Lol. That's way too little money, man. Yeah, this is annoying. I to this day I do not understand. No, I do understand why Executorch did this way, but it's still kind of bogus. Gotta love that stutter. We were talking about TinyGrad on the first stream. I mean, it's cool. You know, I'm as an academic, someone from an academic background, I generally like small, minimal implementations of things. I also think it's a pretty interesting strategy to program the drivers directly. I wish them best of luck. Torch randint. What do we say it needs to be? It's an int64. Torch int64. And we're going to make it 121. And I need to specify dynamic dims. Okay. Torch.export.export. A module that takes a 1D tensor 1s01 where dim1 is dynamic. Write the code. Let's see if Claude actually knows. I think this API is kind of too new though. Oh, come on, Claude. I didn't need all that. Okay, it's using the constraints API. I don't even remember. Is that the API? Oh, wow. I didn't even know about this API. I guess that's how you do it these days. Okay. Sure would be nice to have. Nah, that sucks. Oh, what do I pass to the argument? Is it good? I think this is good. Oh, gotta put this back in. Take a peek at the EP in a moment. Yeah, That looks good. Let's do this. Cursor probably can one-shot this. Yeah, I'm running on a work server as well, so yeah, would be pretty naughty of me to be sending stuff to Sona 3.5. Even all this is open source, it's just like don't want to do it. Cannot import name dynamic div from torch.export. Yeah, because I think we deleted it. I think this is the old API. How droll. Oh yeah, they got rid of it. The problem with large language models. What is it called now? What's this dynamic dims thing? Yeah, that's pretty reasonable, honestly. I'm just annoyed because Claude didn't one-shot it. This new API is worse somehow. I don't understand. It's so strange. Well, look, I'm not doing any of the stuff that I would be doing at work. Like I was working on like reliability of our compiler or a decent chunk of time last year. This is fun. I'm like I wanna use this TDS thing. Like let me just play around with it. Well, I'm doing torch.compile because I get eyeballs for this, but yeah, the reason the dim API exists is because there might be like relationships between the inputs, and so if you have the dim things, it lets you specify that, oh, these are the same size, which is like kind of what you want. That's a lot, especially when something's this simple. All right, our plan of action is once we show that the export works, we're going to use AOT autograd to do it. No, come on. Yeah, low, high size. Navidam asks, doesn't Dynamo figure out that certain dims are related? The answer is yes, but it needs some help. So for example, in the original code here, you can see that they pass dynamic equals true. So what that means is that we YOLO'd everything dynamic. But actually, since the input's so simple, and the first and the last dims are 1, you get exactly what you need in that case. He could have also marked dynamic. That would have worked too. But dynamic's true is fine here. If you don't have this, then we have to compile the static version first. And then after compiling the static version, we then see that you change the dimension later. And that triggers recompilation. That's called automatic dynamic. It's very easy because you don't have to do anything, but you do waste time compiling a graph that like is completely pointless. It takes so freaking long to load the model. I should do a hack to like shove the weights somewhere so I can just IPC them over to this process. Oh, come on. It's not called dynamic dims. It's called dynamic shapes. You can see I never use these APIs. All right. While we're working on this, let's go look at the AOT compile API. I'm good friends with Vincent Mowens, who's behind torch.rl, and everyone's all aflutter about RL now that DeepSeek showed that it works. But I have not actually played with torch.rl. I was always scared away from RL because they told us that it was very difficult to do. So might be one of the things I want to look at while I'm on leave. Did it work? Oh, I gotta pass in all the other arguments. Okay, so. So CFG scale, where do we get that from? That's an argument to generate. So it's the default. And then CG is just the model. Can't use photographs. Let's properly use self.model. And inference params. There's a bunch of stuff actually. Okay, I might have spoken too early. Inference params, we might actually need to do some funny stuff with it. Max sequence, match batch size, sequence offset, batch size offset, key memory dict, length per sample. Okay, we're just going to like bash in the default, but I think that might not be the right thing to do. A bunch of us went to the CUDA mode real world meetup, Napadam, so that might be something to look into as well. I have no idea what this number is. YOLO. Can I make this run faster? I don't think I can make this run faster. I need the model. Alright, if this doesn't work, I'm just going to call it. And we'll pick it up again later. Or not. control flow not supported. Why? Yeah. False. I lied. Yeah, sure would have been nice to use Jiangshu's thing. Problem is I do kind of need to understand what inference params is, though. True. Could also just be that inference params is like totally cooked, and that's the problem. But I don't think there was another Oh no. Yeah, there's more dynamic shapes. Okay. Yeah, that makes sense. Okay. Yes. Okay. All right. We're calling the stream because it's 11. Okay, so here's what we would have done. So we discovered by inspecting the torch.compile graph that there's this extra argument that needs to be dynamic. The module's backbone freaks sys. Actually, is that true? Maybe that doesn't need to be dynamic. Okay, maybe it doesn't need to be dynamic. All right, we'd figure out why we botched the arguments, probably by just actually running the real model and then printing out the outputs and then putting them in here, and then the export will work. And then once the export had worked, we would have then gone ahead and done the AOT inductor call instead, which is this thing called AOT compile. On top of export, and that would give us this PD2 file, and then you can just load it up later and run it, and this happens instantaneously. There's nothing else you need to do. That's where we would have gotten, but I'm cutting it short. Milnus, any unreleased cool things? We're working on a program model for compile, basically like a really good explanation about how to use the compiler, what to expect, like a mental model that will help you predict what the compiler does. So yeah, look forward to that. All right, thanks everyone. See you all next time.
Long text that is from a far-off place called Montana. A short text. And in between not too long. Long text that is from a far-off place called Montana. Long text that is from a far-off place called Montana. A short text. And in between not too long.
Hello, world. I am the one you need. Let me take you to a far-off place.
Long text that is from a far off place called a short text. And in between, not too long.
Hello, world.
Hello, world.
Hello, world.
Hello world. Hello world. Hello world. Hello world. Hello world. Hello, world. I am the one you need. Let me take you to a far-off place. Hello world, I am the one you need, let me take you to a far off place.